motto V naught, our motto determine V naught with the help of Thevenin's theorem. So how can do it? First of all, we have taken that is X and here Y terminal. Okay, and this 1 kilo ohm is parallel to XY. That's why it is considered. This one is considered as a load resistance. Clear? Now second target, next target is our motto. This whole circuit converted into Thevenin's equivalent, and after that 1 kilo ohm as a load resistance is connected between X and Y. Then determine V naught with the help of voltage divider rule. So how can do it? First of all, determine VTH and after that RTH. Okay. So first of all, we have focus on VTH. VTH means V of open circuit. Open circuit corresponding to this one. Okay. So how can do it? First of all, make the circuit that is 2 kilo ohm here minus plus 12 volt, and here 2 kilo ohm, and here 1 kilo ohm, and here 2 kilo ohm, and this one is open circuit, V of OC. Okay. Now next target is that is plus minus 2k into I naught. Clear? And what about I naught? I naught here. Okay. Our motto, determine V of OC. If you determine I naught, then you also got apply KVL in this loop, and then you got I naught. Okay, clear or not? So first of all, we have considered if this one is a ductum node, that is 0 voltages. Clear? And this one is a V1. Okay, this is 0 and that is V1, and this is I1, here I2, and here I naught also going on here in this branch. So apply KCL at that node, then we got I1 plus I2 plus I naught. Now what about I1? I1 is written as V1 minus 0, currently from negative terminal, so minus 2 I naught divided by 2, plus what about I2? I2 is written V1 minus 0 divided by 2, and I naught is written as V1 minus 0, currently from positive terminal, so plus 12 divided by how much? 1. This is equal to 0. Okay. Now after solving this, V1 by 2, and that is 2V1, and this is I naught plus 12, this is equal to 0. So I naught is written as 2V1 plus 12, and this I naught is equal to also written as V1 plus 12. Okay, clear? After that, so what about V1? V1 is equal to 0 volt. If V1 is equal to 0 volt, then what about I naught? I naught is 0 plus 12 divided by 1, so that is 12 milliampere. Our motto, determine V of OC. If minus to plus, if we are going on, apply KVL in this loop. Minus to plus minus, plus 2 into 0 plus 1 into 12, this is equal to 0. So V of OC, that is 12 volt. Clear or not? V of OC means VTH is 12 volt. Okay. Now next target is RTH. How can determine RTH? Basically this is the main target. Okay. First of all, this one is a dependent source circuit. Okay. Why? There is 2 I naught. Here I naught, here 2 I naught. So it is dependent. This one is a current dependent plus minus is given, that's why voltage source. Current dependent voltage source. So how can do it? First of all, make the circuit, and this one is removed. I know that if you determine RTH, then all independent source reduced to be 0. It means this one is short circuit. Okay. If you make the circuit, that is 2 kilo ohm. Here plus minus, that is 2k I naught, and that is 2k ohm, here 2k ohm, here this one is short circuit and that is 1 kilo ohm, and here I naught. Okay, and after that is 2 kilo ohm, and this is load resistance, that's why I remove. So how can do it? After that, here you have assume 1 volt voltage source or 1 ampere current source. Okay, we have assume here 1 volt voltage source we have taken. If we have considered 1 volt voltage source, 1 volt voltage source, then what about current is I. I know that 1 volt voltage source, then I into RTH. So our motto determine RTH, basically determine 1 by I. Okay, basically our motto determine 1 by I. Okay, if you determine 1 by I, then it is RTH. So how can determine 1 by I? If you determine I, then also determine 1 by I. So how can do it? First of all, if you see the circuit, this one, if this one is a ductum node, this one is a ductum node, incoming current, and this one is a V1 voltage, so this one is also V1 voltages. Okay, here I naught, here I1, here I2, okay, here I3. So incoming, so first of all apply KCL at that node, apply KCL at that node, then we got incoming current I and outgoing current I3 plus I0. So I is written as I3 plus I0. I3 is also written as I1 plus I2. So I1 plus I2 plus I0. So what about I? I1 is written as V1 minus 0 divided by 2. I2 is written as V1 minus 2 I0 divided by 2. And what about I0? I0 is written as V1 minus 0 divided by 1. Okay, so clear or not? And what about I0? First of all, you solve this circuit, that is V1 minus I0, or you can say that 2V1 minus I0. Now next circuit is 2V1. I know that I0 is written as V1 by 1. So you can replace I0 is equal to V1. So 2V1 minus V1, this will equal to V1. Or you can say that I this will equal to I0. Clear or not? Clear? I this will equal to basically I0. Now next target is our motto determine I0. So how can we determine I0? Apply KCL in this loop, KVL in this loop. Minus 2 plus minus 1 volt plus 2 into I plus minus I0, this will equal to 0. Okay, clear? So I this will equal to, and I put this value here. So minus 1 plus 2I plus I this will equal to 0. So I this will equal to 3I this will equal to 1. So I this will equal to 1 by 3. It means you can say that 3 this will equal to 1 by I, and this is RTH. Clear or not? So RTH is 3 kilo ohm. Now make this circuit. Making this circuit, that is plus minus, it is RTH, VTH, here RTH, and here RL load, here X, here Y. Okay, here RL. What about RL? RL is 1 kilo ohm, here 1 kilo ohm, and this one is VTH is 12. 12 volt and RTH is 3 kilo ohm. Okay, now next target is our mode to determine V0. So what about V0? V0 is written as 12 divided by 3 plus 1 into 1. Voltage divider rule. We got that is 3 volt. 3 volt is the clear answer. Clear or not? Okay. So how can determine? First of all, we have focus on one by one. Our motto determine V0 with the help of Thevenin's equivalent. So how can do it? First of all, this one remove. That is this one is behave as a load resistance. So first of all remove it, and after that whole circuit convert into Thevenin's equivalent, means VTH and RTH. So how can do? First of all, this one open circuit, then determine V of OC, and after that RTH. Okay, and these value put here and determine with the help of voltage divider rule here, plus minus V0. So with the help of voltage divider rule we got 3 volt is the final answer. Make it.